My name is Jose Lamas. I am product manager at GeneXus for GeneXus Server and some other products on the platform. We're here today to talk about automating DevOps with GeneXus 18. When we start developing, generally we do it individually. However, then the real life of systems very much resembles a regatta than a single person rowing. The world changes, technology changes, and the systems that we are building today are more and more critical. It's not just a mere tool to a business, but oftentimes it's at the very heart of businesses. So the challenge is that we can build these systems that are required by today's world and that we can keep them running and evolving considering the ongoing changes that the world is demanding from us. For this, we need to have the right tools, we need to have a team that needs to be more and more multidisciplinary, and generally you need automated processes. At GeneXus, we have a wide variety of tools that we need to know and we need to start using. In the industry, DevOps automation and everything related to DevOps is a standard at the moment. And in the GeneXus community, we have countless examples, whether it's GeneXus run projects or some of our clients, where automating DevOps has turned out to be a huge case of success. It poses a very good competitive advantage. This may be the difference between between you're done with changing something and you have it up into production. It can take you from 1 hour to 6 months. It presents a huge competitive advantage, and therefore you can't just stay behind. When you're talking about automating DevOps, you're talking about automating the steps that will take you from what you have in a KB all the way to a running system. But at the same time, you need to do this continuously, and that usually implies overcoming a number of aspects that we will be discussing in this presentation. First, we need to talk about the steps that we need to follow. So we will talk about some of these steps and, of course, the tools that relate to these steps. In particular, the final step is deployment. This is one of the most important, critical steps. And for this, you need to take into account and overcome a number of aspects. For example, the architecture of the application that you will have up and running, to the place where you're going to publish that system, what providers, what services you're going to use, and so on and so forth, and the tools that you will need to use in order to make those publications. Another thing that you need to take into account is that this needs to be continuous, and you need to automate, yes, of course, but also you need to trigger those processes, and you want to have traceability. You want to know when these processes were executed, what the results were, and so on and so forth. So for that, we will talk about tools that we use to overcome that, which is basically orchestrators. Going back to the publication step that we mentioned, publishing means sending something to a certain destination. But at the same time, it means that that destination needs to exist. And that oftentimes means creating servers and services, setups, and so on. All these processes, well, it's also convenient to have them automated and formalized, because the more sophisticated architectures are, the easier it will be. So we will also talk a bit about how to work this out, in particular using Amazon tools, which is the Cloud Development Kit. And last but not least, so far we have talked about how to go from a KB to a running system, but oftentimes what you need to do is you need to have multiple instances of the system working based on the very same KB. This can apply to different scenarios, which perhaps could be related to different development versions or publication stages, so we will also be talking a bit about that. Now that I've told you a bit about the agenda for today, let's go to the first segment of the talk, which, as you remember, is the different steps that we need to follow and the tools that are related to those steps. As I was saying, we have different steps, and for each step, you can have different tools. One of the first steps, needless to say, is development. This is usually done by more than one person, so the very first step that you need to solve is about integration. In GeneXus, the integration tool is GeneXus Server, and that is what will allow the development that is being done by multiple developers can be easily integrated. So each developer is going to be using their own work copy that is not connected to the other person's copy, and they can choose when to send or receive other people's changes. And even if you have only one developer, by using GeneXus Server will allow you to have traceability to that development, because to some extent you will be formalizing each of the changes that you're making in the system. In particular, for DevOps processes, the tools in the repository, and in this case in particular GeneXus Server, is at the very heart of all the development processes. So based on the changes that you make to development, once you formalize it through the different commits to the commits to the repository, that is how you formalize processes. Then, of course, you have the build stage, which is the compilation of all systems done by GeneXus. And the system and the tool that we use for this, of course, is GeneXus. And as we run that from GeneXus's IDE, we can run it through different MSC build processes. And after you build it, naturally, you need to verify that what you have built is working the way that you expected. This means to have a testing stage, for which the tool that we have available in the GeneXus platform is GXTest. GXTest allows you to do unitary tests, functional tests, and also UI tests. I particularly recommend you Fabian Baptista's talk about how to do automated testing with GeneXus 18. And especially, it's important to mention that testing can not only be triggered or controlled by the GeneXus environment and from the GeneXus environment, but it can also be automated through different MSC build processes. Another characteristic that we want to mention is security. And for this, we have what we call security scanner, which is given a KB that was built with GeneXus. You can do a checkup for potential security problems following the OWASP top 10 rules and guidelines. Once you run these processes, you can also automate them and take the track and do a tracking of what have been the previous results, compare and contrast them to current results, and that will give you much more control on every aspect related to the security of your applications. Of course, you can have a number of in-between steps in this process. We have just gone through a couple of them and the most important ones, and what are the tools that can help us to follow these steps, but we can have many more steps. The common factor here is, though, that each of these steps should be executed with a command line, which makes it possible to include them in an automated script for these processes. We were saying that a very particular step of this process is deployment. And for this, we need to define what is the architecture with which we're going to deploy our application, which are the tools that we're going to use, and so on and so forth. So let's begin by talking about architecture. GeneXus allows us to define or model the different components in the architecture that we're going to use. These architectures may range from a simple application, a web application with a database, to adding mobile applications or service backends, batch processes, and so on and so forth. Whichever the case may be, GeneXus will allow us to define what we call deployment units that will encapsulate each of these applications based on the definition of the main objects. GeneXus, of course, has the capacity to calculate the dependencies that exist based on that, and therefore it allows you to achieve or to determine which are the binaries and configuration files that are necessary for each kind of deployment unit. Then for each deployment unit, you can ask GeneXus to deploy that application, and that will take you to the deployment tool, where you can select the destination where you want to publish. A destination means a provider. It could be Amazon or Google or Microsoft, IBM, and so on. And of course, a type of resource where you're going to publish. It could be a computer, it could be a container, a service as a platform, and so on. So in this case, we've done it from the development environment. But again, these steps can be also done through command lines, which takes us to the next point. Because when we talk about deployment, we are saying that we want to do this not just as steps that you can automatically follow, but rather as steps that will be a part of a flow that is automatically executed by itself, and that will give you results, which takes us to the next point that is precisely related to those tools that will allow you to have that orchestration in place. And as part of that, we're going to see a couple of examples. So let's begin by Jenkins, which is the first option. It's an orchestration engine for flows, and it's open source and it's practically a standard in the industry. In particular, GeneXus and GeneXus Server give you specific integration with Jenkins after version 17. That means that once that you have in GeneXus Server configured the association with a certain instance at Jenkins, you can, from GeneXus or from GeneXus Server, create different execution pipelines with something as simple as that, saying what the KB is, what the version is, the environment, and with that, it will automatically create a basic pipeline in Jenkins. What you can do is you can extend it going to Jenkins. What you will find is a script that tells you the different stages and steps that you want to follow. And precisely the way to extend this flow is by adding other steps that will be executing other tasks, always using the execution of tools through command lines. And to make this even easier, we have been working lately on a library that we are sharing with you that allows you to, using property files like this one, which declares the knowledge base, the environment, and some configuration data. These property files are used by scripts, Jenkins scripts, that are even more declarational at a much higher level. Because, for example, here you have a job that what it does is it builds a GeneXus KB. That's all it says. And from these property files, it allows you to produce something like this. These are multiple pipelines that in this example in particular refer to the automation of continuous deployment processes in an application. You get the KB together, you package different deployment units, and you deploy different resources. The application that we are deploying in this case is the plant care application, one of the examples that you can find in our websites. You have the knowledge base and you have all the information for that application. Back to the pipelines that we were just seeing that we were creating through this mechanism, you can see that the first pipeline refers to something that is mentioned as simply building the knowledge base. And then you have a package and a deploy for 3 different deployment units. What is here shown as simply building the knowledge base actually comprises multiple steps that you can see in further detail on this slide. This implies, amongst many other things, to optionally updating a certain GeneXus installation. You can update the KB based on the last changes of the knowledge base. You can do the build. You can check whether or not you have an organization that needs to be done, packaged, applied, and only then it will generate the specific pipelines so that you can do the packaging and the deployment of each of these deployment units, as we were saying just now. Similar to this, the different pipelines that refer to packages and deployment also comprise multiple phases, multiple steps. Packaging implies, amongst many other things, creating the package of binaries for that deployment unit, but also creating and registering a Docker image for that publication. And then in the deployment stage, the deployment pipeline will, based on that Docker image that was generated in the previous file, it will create the Docker compose file for that deployment unit. And it will finally deploy it to the destination that was selected. So Jenkins is a very popular option. Another very appealing option as an orchestrating tool that you can use is what we call Azure Pipelines, which is a part of Microsoft Azure DevOps. We've been working quite a lot on this, and this gives us the possibility to have highly declarational pipelines. This is an example of a script And what you can see here is a series of properties with the corresponding values. Some properties have to do with what is being put together, some others with what is being deployed and where, what credentials, etc. And then a number of steps that are also declared to be executed. And based on this kind of scripts that you can see in Azure with the executions and so on, you can create typical continuous deployment pipelines in Azure DevOps, which range from a KB to an Azure web application deployed in Azure precisely. So in summary, we have seen some options of orchestration tools, but these are just a few examples. Needless to say, you can extend this to other engines using the same kind of tool. These workflows, these pipelines, as we were saying, deploy to a certain destination. And as we've already mentioned, these destinations need to exist in a certain provider. So you need to define your provider and you need to define your technology, but also you need to create the resources that will be specific to the publication that you will be making. That is what you call provisioning. And about this, I would really like you to take a look at Gonzalo Galotti's talk that talks about how to build using GeneXus 18 this kind of modern applications and systems with infinite scalability. And in particular about this application, which is a good example. It's called Festival Tickets. And it's a ticketing application for different events that has a very sophisticated architecture like this one. This is an example of a modern native system. It's, as I was saying, an application that is used to book tickets and buy tickets online. And it has an architecture that has infinite scalability. Amongst its components, you can see in the diagram on the screen that you have an Angular application that is accessed through a CDN. You have API gateways. You can use message queues. You have a connection to non-SQL databases. You have functions or daemons that are being executed every couple of minutes. And all of this runs on serverless platforms, which provides you infinite scalability and automatic scalability. All of this uses AWS Cloud Development Kit. We are sharing here on the screen a repository where you can see this example, but Gonzalo's talk precisely discusses how to build it. And it would be interesting for you to pay attention to this part, which is precisely about the deployment when you use infrastructure as a code. So the resources, the services, the containers, everything that you need to put the system into production is created as part of the automated flow. So far, we have walked down the path of the different processes from the simplest ones in terms of size and architectures to the most complex and sophisticated options. But so far, we have always worked on processes that go from the KB, as we said before, to a production system. However, in many cases, what we need is to have multiple instances in the system that need to be working with one knowledge base. And this should be able to manage different scenarios because we need to separate those systems that are working in the different dimensions that we will see just now. So the first one is related to the different development branches or development versions. These different versions are modeled in GeneXus server. And from these versions, the different automation processes may generate different instances in the system that is up and running. So in this way, you can have a system that is up and running associated to the initial development stage with developers. You may have a different instance that is going to work based on a development version where you already have all approved changes that is a bit more stable, let's say, or you can have an update line and so on and so forth. So for each of these development lines, you can have the same automated process and you just change the version and, well, the features that may depend on that will vary. So that gives you the updates of the different respective systems. Another dimension where we normally need to separate instances is related to publishing stages. Normally, we don't put everything that we have just released from the point of view of code into production. Normally what we have is previous validation stages that are called integration, testing, pre-production, production, and so on. So a very important point for these flows is that normally you don't go back to doing all the build and generation and compiling and packaging of each of the components in the application. But in these cases, the flow goes down 2 rows in deployment time. So the same packages that you obtained for the first stage are then promoted as such, and you only deploy each of the different systems that you have associated to those stages. A very similar case of this two-way street is when you try to separate the different installations for different end users or end clients. This is what you usually call a multi-tenant system or deployment, which oftentimes happens at code level or database level. But in this case, we're talking about doing this only when it comes to deployment. So the same package is published in different instances and for different clients. This gives you some advantages compared to the other version, which is that it will allow you to have much more isolation between the different stages and instances of clients. And that has to do with security, privacy, and even with the granularity with which you do each update. So you can update each instance for different clients, depending on what you need or what you coordinate with each of them. It is much easier to scale it up or down. That means to add systems for new clients, or maybe dismissing some systems that you don't need anymore. So with this, we have talked about automating DevOps. We said at the beginning that the challenge is to be able to create applications according to what our nowadays world needs, and to do it efficiently and fast, and have them up and running and keep evolving them depending on the different needs that you will get from the market. This calls for tools, processes, and teams. This may represent the need to learn a lot of new things for a lot of people. And as usual, the best way to learn something is to get your hands on it and learn by doing. And it will allow this to work in your favor. Thank you so much.